problem, if you need a fertilizer, if you need any of our technology, we are happy to provide to you. Also, there are many different ways of the urine collection at the Melbourne University, also UTS, in also Brisbane. So we have a different scale and different also technology to support you. So if you need any help, please during this summit and conference, please let us know. We are very happy to discuss and then support you for this project. And that's what I can say that. And then I'd like to thank you for our organizing committee. First of all, our plenary speaker, he came the last Saturday. And then he has a jet lag so far. And then, so he has been also Bondi Beach and then Blue Mountain for the last 2 days. So he enjoyed the citizen life here. Now he's very happy to have him here to listen to his experience. Also, I'd like to thank you for our hub manager, Ibrahim Al-Salimi. So he's over there. Also, our communication coordinator, Jade, she's in the registration desk. Also, the social media coordinator, Wanjang Sean. Also, organizing committee. Also, thank you to everybody to make this summit very successful. And then happy to work together continuously for next 3 to 4 years. And we can start our summit officially. Thank you very much. So today, first speaker, Abraham NiCE. So let me briefly introduce him. And Abraham NiCE is the co-founder and research director of the Reach Us Institute, which operates the nation's first community-scale derived recycling program and conduct research relating the reclamation resource from the human urine. So he is also the Chief Technology Officer of the Reach Us Tools, and which develops the technology for productive sanitation, particularly for concentrating and sanitizing source-separate urine and vacuum process the backwater for fertilizer production. So just 2 months ago, I went to his institute, very close from the Boston, just a 2.5 hour distance. So I drove there, and then his area is the Brattleboro, and then there are many community people to support his project. So they collect from the resident. Also, they have all the collection logo. Also, they collect from the pubs, and then some of the opportunity of the public area. Also, they have their own public toilet, also portable toilet. So they are one of the most active urine diversion and fertilizer research institute. Also now they are planning to extend their research to commercialization opportunity. So they have some of the collaboration in Australia. Also, they are looking for more collaborative opportunity in Australian company as well as the research opportunity. So they are also very welcome for the exchange student or exchange the internship. So please work with them. So they will give a lot of good tips and experience for the urine diversion system. So please join me welcoming the Abraham NiCE presentation.
Thank you so much for that very kind introduction. I am so happy to be here. I'm very honored to be addressing you all this morning, and look forward to sharing ideas and learning a lot about what you've been doing over the last year. I'm also very appreciative to Dr. Ho Kyung-shun for bringing me here, inviting me here, and involving me in this, and likewise to everyone, the conference and summit organizers and the ARC NiCE Hub folks who helped me out so much and have given me a really warm welcome since I landed here on Saturday. So I get my timing right here. Should I end at 10 or should I shoot for the?
So you have a flexibility. So
Okay,
you can
okay.
end whenever.
I'll try to not go too much past 10 then.
Yeah.
Maybe go a little past. Okay, great, wonderful. So yeah, I'd like to share some experiences and findings and thoughts with you all from our last 10 or so years of working with urine diversion, and so much of the presentation is about just a mashup of many of the things we've done over the last decade and some of the lessons we've learned from that, and then I end with our take on what three of the most promising avenues are for where urine diversion could be applied in the United States, at least, where it addresses some active practical need that could give it footing to actually be widely adopted. So to give you just a little context, where we are and where we're situated, this is the upper corner of the map there is Vermont. That's where the little pin is. We're the second smallest state in the country by population, and we're just north of Massachusetts and just east of New York State. And this is the town of Brattleboro, and it's a small town, a little over 10,000 people, and we're a rural state, a lot of forests, a lot of farms, and our climate is characterized by warm, humid summers and cold, snowy winters, which has an effect on agriculture and also on how we can do our urine diversion. And our institute is really founded and directed specifically at this same issue. Our vision is a world with abundant clean water and fertile soil, achieved by reclaiming the nutrients from our bodies in a life-sustaining cycle. And we accomplish that, or we strive to accomplish that, by engaging in research, education, and technological innovation to advance the use of human waste as a resource. So a lot of commonality with what you all are engaged in, I think. And we are driven by the same fundamental fact that human waste is less than 1% of wastewater. Wastewater is essentially tap water with a little bit of other stuff polluting it. And our motivation is to grab that human waste before it gets mixed in and use it as a resource. And of course, the fact that urine contains most of the nutrients and about half of the micropollutants makes it a great material to grab out of the wastewater stream to address most of the wastewater treatment sort of requirements in one very small concentrated material, and to aim for resource recovery rather than just water treatment. And in our area, one of perhaps the biggest driver, and the thing that is politically and socially most on people's mind, is water quality. Because our biggest lake, Lake Champlain, is heavily impacted by phosphorus, and then where our biggest river drains into an estuary and into a Long Island Sound is heavily impacted by nitrogen. These dead fish are all from that nitrogen pollution. We founded the Institute back in 2012, and it was a grassroots organization, meaning that we weren't initiated as a program of some larger organization. It was just Kim Nace and I decided we wanted to do something with urine, and so we called ourselves an institute, and we raised $1,000 in seed money to buy some small amount of supplies. And I already knew a farmer who was excited about the idea, and we recruited 60 people that we knew and people they knew to urinate into containers and bring it to Kim's house. And we talked the state into giving us a insignificant waste management approval permit, meaning this is a little thing, you're going to do it once, and it's not too dangerous, so we'll let you do it in this one little spot, this one little time. And that's where we started. And we did it just because we felt like no one was doing it in the States, other than homeowners were doing it, gardeners were doing it, but no one was doing it in public. We wanted to start the conversation. We did that in 2012. This year in 2023, we have about a $500,000 budget 230 dedicated urine donors who participate around the year. And we collect 12,000 gallons, we collect about 45,000 liters. I wish we didn't use imperial units anymore, but we do. And we are doing a bunch of different research. One thing we do is multi-year field trials looking at soil health with a couple other universities, but you'll see in the presentation other forms of research as well. So it's come a long way in 10 years. It's been a really exciting ride. And one thing that in terms of lessons learned definitely is that this strategy worked. The strategy of just starting by doing it, telling people we were doing it, and just doing the bare minimum to do something on the ground and start that cycle worked. Because now we have this urine nutrient reclamation program. It's the first community scale urine diversion program in the US. And there's a few key factors for what has driven its growth and success, I think. One of them is that the participants, I can't really point on that, it's too bright, but I can point my finger. The participants are geographically scattered. So this is not like a development that we talked a developer into. It's people all over the county who want to be involved. They do this in their homes, in their offices, in their businesses. They can participate inexpensively, and I'll show you why in a minute, how they do it. They choose their own collection method, which is related to that. And we recognize them for their efforts. There's a community around this, and we have a competition every year. We call it the piss off. I don't know if that translates. I guess it does. And so people log how many gallons they collect, and we have a trophy for the grand prize winner. We have certificates that go out. People are very proud of this. A press release in the newspaper. It's full on. And people are motivated by different things. Some of them it's water conservation, some it's pollution avoidance, and some it's fertilizer production. And the way that we do this, the logistics of it, is that people can have, if they do the low budget introductory way, they have just a 20-liter container with a sealed lid and a screw top to a funnel, and I'll have more on that later, that they then drive when it's full. They take the funnel off and put a cap on it. They drive it to a depot and pump it out, or they empty it into a barrel on their property, and then we come with a truck and we empty the depot or the barrel, or they have a permanent porcelain fixture that goes to a storage tank, and then we pump out their storage tank. We bring that to a treatment facility, and then we pasteurize that, and we bring it to the farm and apply it to the farmers. And for collection, we have now 2 of these urine depots, and over 200 donors who bring urine to the depots. We also have about 19 installations of porcelain or others. Some of them are composting toilets, but urine diverting, and we pump that out with our truck from the house, so it's very low effort from the homeowners. Then we have urine diverting portable toilets, 17 of those. We rent those out. That's a profit-making part of our service, that we rent it out to events and wherever. And the urinals are connected to a tank, and then the seat is connected to a larger bin, which we then take all those solids for recycling, for composting elsewhere. This is the low-cost collection system we have. It's very low cost. It's very homemade, but it's an introductory way that we've approached it. And we used to really not talk about it, because this is sort of like the very do-it-yourself kind of thing, but I'll tell you why we talk about it more now. What it has is it has this 20-liter container, a little sleeve around it if you want that for aesthetics, and then plumbed connections all the way up, watertight connections up to the funnel. This plastic ball goes in the funnel, so that floats up and urine goes in and settles down. That seals it against odors. And some people also add vinegar to it before they fill it to inhibit urease and keep the nitrogen in the urea form instead of the ammonia form, which eliminates the last remaining faint odor from it. And women can use a P-style is one thing we offer is for standing to urinate, or the nun's cap or the hat from hospitals that fits under the seat, and then they pour that in. And then when it's full, they detach the funnel, put on a cap, and this is a vacuum pump out station. That photograph is of the actual unit. You put your jug in the unit, you pull down the handle, the wand goes in there, it activates the vacuum turbine that evacuates the vacuum chamber, it sucks all the urine up, and then the turbine turns off and it dumps the urine into the container, and there's a series of them interconnected, and then we can pump that out with the truck. And we actually really promote this jug system now. It lets people try it out. It lets people have no commitment. They just pay about $50 for the system. They can take it home, try it out, get excited about collecting their own urine. They can even use it in their home garden while they've got it. And then some of them graduate to a plumbed system, because it is work to take that jug. You get tired of it eventually. but it's a way you can say, well, I'll try this weird idea, and then once you're doing it and it's like, oh, this isn't so hard, this isn't bad, I like this, then you can graduate to a plumbed fixture. We do a couple of Wostmans, the dry and the flush. We also have one of the Laufin Save toilets with the hidden teapot effect, urine catchment that probably you're familiar with, but we have one in our office that we're quite happy with. And then this is the pump out. We come with our truck and hook a hose to a port on the side of the house, evacuate the urine, and take it on our truck that takes 4,000 liters at a time. We built that vacuum system on the front, and then we have a flatbed truck. We can just have as many tanks as we need to in there. And then we pasteurize it. And this is where our spin-off comes in. We built a few pasteurizers at the Institute over the years, just in order to manage our own urine treatment needs. But our spin-off came out in 2019. It's called Brightwater Tools, and we're building equipment for on-site urine processing and fertilizer production. And the first thing we're offering now is this pasteurizer. We've sold 6 of them now, and it pasteurizes urine at 80 degrees Celsius for about 1.5 minutes. That meets a US EPA standard for sewage sludge, so it is far above and beyond what urine actually needs. But it means regulators are happy with it because they say, oh, it checks that box. We've already approved that system for much dirtier material, so you can pasteurize and use it. That becomes a Class A material that we can then distribute without really any further regulation or restriction of use. So it can go to home gardeners, it can go to farms, it can go to wherever it needs to go. And so Brightwater manufactures those and sell them. That green building is where Rich Earth Institute and Brightwater both exist, and those are just some of our urine tanks there on the bottom. We store all of our urine above ground and outside, and even in the winter that's fine, because as we'll get to in a later slide, when urine freezes, it doesn't freeze like pure water and break the container. It freezes and begins to form a sort of a matrix of ice with brine in it, and so the brine can always scoot to the top, and it doesn't exert any pressure on the walls. So that was a nice thing. We don't have to worry about the cold. Then we apply it. We take it to farms and supply it to farmers. We sell it to some farmers. That's been a new thing, but originally we were just giving it to farmers in exchange for them participating in our research and helping us in our work. So this is a tractor-drawn applicator. That is a 2,000-liter applicator, and it's being used on perennial grass here for hay or for pasture. And that can certainly scale up, but that's the scale that we're doing it on now. And it comes out in those streams onto the ground, so that it's not a spray. It goes down, because we don't process the urine into another form. This is just pasteurized urine, so it's very high in ammonia. We also have used it on sweet corn, which is a sweet variety of maize that we boil up and eat fresh. That farmer is very proudly showing it off. He's very proud to be using urine fertilizer. And what we're doing on here, you can probably barely see, is here's a tank on the back. There's a hose running in, and there's a cultivator tines here. So it's turning the soil to kill the weeds, and the urine gets poured down onto the ground and then immediately buried. So the ammonia doesn't volatilize because it's buried under the soil. And so we've been trying that, and then also a method for getting into the soil is drip irrigation. And AVOG did an early project years ago on that, and so we thought we'd give it a try. A little bit of concern that the minerals in the urine would form deposits in the drip irrigation emitters, but it didn't with medium hard water. With very hard water it did, and we're working on ways of pulsing the urine so that it doesn't mix as much with water. But for most water, it's fine. And we grew hemp, or we supplied it to a hemp grower, and they saw a 6% increase in the CBD content of the hemp, and then a 32% increase in this particular chemical, the CBDV, which they were happy about. And then we also, at our research center, have an anthrovermoponics setup. So there's a worm composting tower where a lot of potassium and phosphorus and other elements come out of that food waste that gets directed into the vermoponics, or the hydroponic system. And then the urine supplies some of those materials, some of those elements, and then all the nitrogen. And I'm very curious about actually the life cycle impacts of this kind of growing, but we haven't analyzed that yet. But it is a wonderful showcase, and people really engage with it. They walk in the door, they see this wall of green lettuce and other plants, and they can eat it, they can taste it, and say, oh, that's delicious, it's fresh. This does not taste like pee. And that's, I think, another lesson we've learned is that that when people see it, they like it. When they just think about it, they're not as sure about it. So being able to demonstrate, like, this is a nice thing has been very valuable. We've also had a lot of education about regulations, because when we started, we had a pretty informal process. We got a permit for treating and applying the urine, and originally we treated the urine just through time storage, 20 degrees Celsius for 1 month before we applied it on the grassland, and so we only had that permit. We didn't look into or pursue plumbing permitting or wastewater permitting, because we weren't really squarely in any of those permit fields. But over the years, the regulators have heard about us and sort of pulled us into their regulatory spheres. Fortunately, we've had time to do that. Didn't have to do it all at the beginning. Plumbing is a place we've made some inroads. The IAPMO, the International Association of Plumbing and Mechanical Officials, I believe, they produced the UPC plumbing code. I'm not sure what you use here in Australia, but we were invited to work on a urine diversion and composting toilet supplement to that, which we did, and that has been useful in the U.S. and I think it's available around the world. It's also an ANSI standard, so it can be used as a supplemental standard, even where the UPC isn't used. So that's been helpful, and we ended up working with the state of Vermont. I always laugh at this. This is an engineered drawing of someone emptying a jug into a barrel, but it has all this particular information about it, and it's approved as an innovative alternative system for wastewater treatment. And it was a whole pain to get it approved, but now it's something that anyone in the state of Vermont can do this. It costs $1,000 to do all the legwork to get the permit, which is a big barrier, and we're working on that. But it's now legal for people to collect that jug, and with a special spout that doesn't splash, empty it into a barrel and we pump it out. Also for the plumbed system, that's also permitted. And we're sharing these drawings with anyone in the US, or of course, if there's any use here, we're happy to share it, for showing to regulators and saying, here's an approved system in another jurisdiction, and here are the aspects that go into it. We also have a whole branch of our program that's social research, and a big part of that is farmer engagement, working with farmers. It sort of all started when I met a farmer I'd worked for before. I met him at the hardware store, and I was talking about this idea of urine diversion. He said, "Oh, I'd love to do that because I'm organic. I'd like the nitrogen." So we've always been going back and talking to farmers, and part of the underlying principle of our whole program, the whole urine recycling program, is that we're doing it. We were doing it from day one. We're doing it as a full cycle. So collecting all the way to application and growth of agricultural products, because we figured we would find out where the problems were that way at the beginning rather than down the road. And so part of what that process means is working with farmers who say, well, it takes a long time for the gravity feed to empty this applicator, so we're working on a pump system to make that go faster. And then questions about, well, the ammonia volatilization. This is a manure pit, and the manure, the dairy manure, is similar. It's got a lot more phosphorus compared to nitrogen than urine has, but the nitrogen evaporates. They've got that same issue. So I'll get to that later. But yeah, we're driven by farmer needs in terms of our ag research, and then we do a lot of stakeholder engagement in terms of interviews and dialogue groups for the public at large and for farmers, because sitting people down and talking with them, we get a sense of what people's, just off the street, what their concerns are, what interests them about urine diversion. That helps us direct our research to be applicable to what people will actually in society, how they'll receive it, and helps us work toward a future where the tools we develop or the strategies we recommend are supporting people and including people, rather than perhaps being extra burdens on people in terms of cost for housing, and maybe people who are least able to afford it are then impacted by something we want it to be a green intervention. And then the thing that I am most, I always just come back to and most impressed by and surprised by is that whenever we've talked to people, the whole time we've been doing this work, they always, when we explain, here's why we want to do urine diversion, here's why it's great, they say, well, that sounds great, I think it's great, but no one is going to be ready for that. The world's not ready for that. You know, the next person you talk to is not going to think that's so great. You talk to the next person, they say the same thing. And so that's an ascribed attitude. It's an attitude that people think other people are going to have, but it's not the attitude they necessarily have. So getting folks together to talk and realize that, oh, no, actually, we all think this is kind of interesting. Not everyone thinks it's great, but it's surprising how many folks do. And that is a takeaway that has really given me a lot of confidence in talking about it and thinking it can be adopted, and also has changed the way I message, because we never apologize for what we're doing. We never like say, oh, this might be kind of gross, but I don't think you all do either. But that's been something we learned, and at the beginning I was very nervous and hesitant about, and have become much more confident. One thing people are concerned about or have questions about are pharmaceuticals. And you know, are there medicine residuals in my pee? What happens to that? Will it end up in the food? So our first academic research project was teaming up with the University of Michigan, who had National Science Foundation funding to do pharmaceutical testing. So we did all the field trials. We grew corn, no we didn't. We grew lettuce and carrots for 3 different years, and collected samples of plant tissue, of the soil, of the groundwater, and lysimeters below it. And we used urine we collected. We also collected urine that we spiked to the highest reasonable level you would expect in a community collection system of over a dozen different pharmaceuticals from different pharmaceutical groups. What we found were detectable but very small levels of several common pharmaceuticals or drugs in plant tissue and in the soil and the water. But the levels were quite quite small. To get 1 cup of caffeine worth of coffee, you'd have to eat a pound of lettuce every day for 2,000 years. So very small amounts, vanishingly small amounts. To get 1 tablet of paracetamol, you'd have to eat 150,000 carrots. In one sitting, that's a lot. So our takeaway from that was that it wasn't really a big exposure pathway for pharmaceuticals. And we don't currently remove pharmaceuticals from our urine. We explain this to our farmers. They say, well, that seems reasonable. But it's a kind of a long explanation. It took me a couple minutes to explain it, and for you all to like hear that and accept that as a sufficient explanation, you have to kind of have a trust in numbers or in concepts of concentration, relative concentration, and concentration being an important factor. And there's some people that that's not what they just hear, oh, you detected pharmaceuticals in this food. I'm not sure how I feel about that, which is why a lesson we learned from that is we still want to remove pharmaceuticals, even though we don't think this necessarily truly necessary. It's not necessarily necessary, but it is necessary from a perspective of just public understanding to be able to say there are very small levels, tiny levels, and then we do a step that removes X percent, 90% of pharmaceuticals. That's sort of a belt and suspenders approach, and it feels a lot more solid in terms of just getting everyone on board. Another thing we learned, from our farmers was that the ammonia volatilization is a concern. It's a consideration, and we did some testing and found there is some level of volatilization. We might lose. It's hard quite to quantify, but it might be 10 or 15% of the ammonia being lost to evaporation, depending on the soil moisture levels. And so we've been working on bioacidification, and that is using a carbon-rich waste material, or it doesn't have to be waste, but for us it is, to mix with the urine or other liquid manure, but in this case urine, and that carbon-rich material ferments to produce lactic acid or other organic acids that lowers the pH of the urine, and the low pH converts ammonia into ammonium, which is not volatile. And in order to try to do this in a circular economy sort of way, we used 2 materials that currently have disposal challenges in our area: whey from cheese making or yogurt making, and short paper fibers from paper processing. Both contain high amounts of organic carbon. And we made different recipes of those and mixed them with urine in different proportions. The red line is the control, and then the other ones are all the recipes. So the x-axis is time. It was a 100-day trial in little 50 milliliter tubes, and the pH is on the Y scale. And you can see that the urine as a control stayed in the 9, 8 range, and then the different recipes all dropped to different degrees. And some of them dropped very low, some almost reached 4, and others were a more moderate decline. But it definitely was effective, and I'll other slides kind of discuss the different versions there. One thing I want to point out is that that the warm treatments work better for some recipes, and the cold ones work better for others. And at the higher levels of whey addition, the warm levels let it, I think, digest further and faster and go more acidic. But at the lower levels, the cold condition worked better, potentially because it may have inhibited microbes that would have just consumed that carbon substrate and not made acid, but made something else, made methane perhaps. And so at the cooler temperatures, it actually dropped further at the lower whey proportions. And we also tried cultured and uncultured, so we added a bunch of bacteria and microbe stew to some of it, and that was definitely helpful with urine. Then we simulated land applications. So we had these jars where we put a little beaker of the fermented urine, and then another little glass of boric acid solution to trap any ammonia that evaporated, that volatilized, and then a little CO2 trap as well. And after certain periods of time, certain numbers of days, we would test the traps, titrate them to determine how much ammonia had been captured. And what we found was these are four recipes for the urine that are most revealing, I guess. And the red one is the control. So we had about 8 grams per liter of nitrogen in the urine, and in the control, over a few days, say over 5 days, in these bottles, we lost over 4 grams of nitrogen. We lost more than half the nitrogen to volatilization. So if we'd applied it in the field, it'd been dry, no rain for a few days, we would have lost a lot. And then the two upper green and blue lines are 6%, 6.25% sweet whey or acid whey by mass added to the urine, and those both had significant reduction. The 12.5% acid whey cut volatilization by more than 50%, and then the 100% acid whey, so the equal parts of whey and urine, dropped it to almost nothing. It's a lot of whey to add, but there is some literature suggesting that lactic acid bacteria can be a biostimulant, can be something that encourages plant growth or improves plant health. So our next step is to look at whether we perhaps could be making not only a fertilizer here, but also a biostimulant. Okay, gotta keep moving here. So another area we've been working on is concentration of the urine, because it takes a lot of space to store urine. We do a lot of short hauling, so we collect it within a few miles and take it a few miles to farms, so it's actually reasonable to move it unconcentrated. But if we were taking it longer distances or needing to store larger volumes, it would become impractical and energy intensive. And in order to make this actually a positive environmental intervention, where it is using fewer resources than conventional wastewater treatment and fertilizer production, we want to do this in a concentrated way so we can distribute it without the transport costs being exorbitant. And we are working on freeze concentration because it can concentrate urine effectively. It's less prone to fouling than reverse osmosis, and it consumes less energy than distillation, because the heat of fusion, of freezing water, is about a seventh, I believe, the amount of the heat of vaporizing the water. So that phase transition, freezing, takes a lot less energy than distilling. But then the trick is energy recovery, which there's methods for in both approaches. Well, just a moment to talk about the hows and the whys. When you freeze a solution, any solution, the ice that forms, like I was saying before, is pure water ice. It's a pure water crystal, and all of the solutes remaining in the liquid, it's unfrozen. And so if we partially freeze urine into ice, say 75% ice, then 25% of the liquid is left containing all of the solutes. We can drain that and have a concentrate, and then drain the ice and have our effluent. And it's physically simple. It's very resistant to fouling. And the energy recovery process is that this part is it's two chambers. This part's freezing. This part is thawing. And our heat pump is taking heat out of the freezing side and dumping it into the thawing side. So there's a very small temperature differential. And this is just sort of a crude schematic of that. Here's the freezing part. There's the thawing part. And this just symbolizes the heat pump with energy coming in terms of electricity, and then much more energy being moved through in the form of heat, because there's a high coefficient of performance, because there's a very small temperature differential between the two sides, only about a 12-degree temperature differential between the two thermal transfer surfaces. And so we did several, more than several, we did a lot of trials on this with a 10-bottle setup, getting all the different fractions that came out, and found excellent partitioning. So these are, each column is a bottle, and the first two columns had the vast majority of the nutrients, and we went from up to over 50 grams per liter of nitrogen, which is about a 6x concentration. This is after a couple stages of the process. And then we had a little middle range that we recycle back into process again. And then our reject water is sort of like our effluent, has less than 10% of the nutrients in it. And we can dial it in to be more or less depending on where we put those cutoff points. But it's quite effective. And in terms of energy usage, it all comes down to the temperature differences that we have between the two sides. So this is the ideal maximum coefficient of performance versus the temperature lift, and we had between 10 and 15 degrees of lift. So theoretically, we could be having a coefficient of performance in excess of 20. Now, in reality, refrigeration is only maybe 50% efficient, and there's other losses in the system, but there's potential for a coefficient of performance of much higher than Unity. And so we're optimistic that with further development, which Brightwater Tools is doing, we'll get an energy efficient system that can probably use more energy than RO, but not much, and hopefully use a lot less than distillation. So to wrap it up, I want to talk about the places we see a lot of potential for urine diversion to have a positive impact and be adoptable for reasons other than just thinking it's a good idea. So actual practical considerations. And for septic systems in the United States, and I'm sure other places as well, there can be a big issue of essentially nutrient injection into the groundwater, where nitrogen goes right through the system, goes through the drain field into the groundwater, and then ends up in surface water, and that is nitrogen pollution in downstream. Phosphorus can come through there too, depending on the soils. And this is a big issue in Cape Cod. So there's the United States again with Massachusetts in red. That's the state just south of us. And there's a blow up of Massachusetts. And the Cape, that arm coming out there, has a town of Falmouth where there's a real hotbed for trying to do something about this. Because they have a problem. They've been told by the EPA, ordered by the EPA, to reduce their nitrogen emissions very significantly. And if they do it by sewering, it's going to be between $50,000 and $100,000 cost per house connected, which will be borne by the town in general and by the homeowners. And it's an incredible cost, and it will make housing unaffordable for people who are having trouble affording housing already. And so that's a serious problem. And the build out is over decades. It will be maybe 40 years before all that can be built. So there's a Pond Coalition environmental group. There's a grassroots group of folks who are promoting urine diversion, who bought a bunch of these jugs and funnels from us. And there's the Massachusetts Alternative Septic Test Site Center, which is a government body, and they do testing of nutrient removal systems on in an in-ground test system. They are very excited about this, and they're providing the technical support and the credibility for it. And this is launching as a sort of its own little grassroots initiative, because they have this crisis, this affordability crisis and this pollution crisis. And you can see all these red dots are coastal ponds or little estuaries that are in unacceptable condition. And then everything except for these little light yellow colors are out of equilibrium in terms of the nitrogen flux. So there's more nitrogen going in than can be safely handled by the ecosystem all throughout the Cape. And so we sent down a whole raft of these down to Cape Cod. There's over 30 people now using these jugs, and they're working on the next steps. And then this just came out a couple of days ago. And I just want to read this part. The State Department of Environmental Protection has recommended that rather than doing a urine diverting pilot program, the town of Falmouth should skip the pilot and instead apply for provisional use for urine diversion. If the town chooses to proceed with this application, it will take years off the process of getting general use approval. So this is kind of shocking to me, is that someone somewhere in the regulation in the government is saying, let's actually do this, which is new. This is 10 years the Green Center has been pushing for this, and now it's finally getting a little bit of traction. So that's extremely encouraging. Then another use case is just direct use of urine on site or right nearby to meet fertilizer needs. And this project has nothing to do with us. We just admire it very much. It's in Niger, and it's this federation of farmers who are collecting urine and using it to increase yields and to support their health of their families by being able to better grow their own food using urine, which they have renamed. They call it Oga, which means boss. It's the boss. It's like a powerful thing, and they don't want to call it urine because they don't like urine, but they don't mind having the boss help them out in the fields. So that's kind of their own idea for their own rebranding, and they've got 3,000 farmers doing that. In our area, we run an education program, and we've gotten some grant funding to do that, to just do outreach to people who want to use urine in their own gardens, and we just share information for them on how to do that. And one way is using their own things you can get locally or just make out of stuff everyone can get. Then there's also the pea cycling kit that we offer. People can buy it online. We have an Etsy store, and they can just go and order it. We ship it to them. And then there's these more expensive but nicer, more established units they can buy to collect urine at home. And then we have recommendations based on the World Health Organization's recommendations on how to deal with health and how to protect health and deal with sanitization. And for direct use of urine, that is just urine where you urinate it into a container and you're going to use it, that we recommend you wash your hands after you apply it, and you wait a month before eating raw food. But that's it, because it doesn't have the fecal contamination. And then if it's a larger project or it's a urine diverting toilet, then there's the storage that the World Health Organization recommends, and then also pasteurization as an option. We can supply pasteurizers to projects, which we've been doing. And some of the projects we've been doing are the Cape Cod or other organizations that want to have pasteurization and do it as a permitted larger project. And then we encourage people, since the nutrients in the urine are so soluble, that they are careful when and how much to apply. So don't apply it all at once, and apply it when the plants need nitrogen, between the seedling and the flowering stage, when the nitrogen uptake is the highest. To do it on plants that need the nitrogen, and wash your hands after you apply it. Put the urine on the ground. Don't spray it in the air or spray it all over the plants, and get it safely into the soil, because it has that volatile ammonia. And so we recommend that they have the order here, right? One is bury it under a furrow, one is irrigate it as you go or put it in the rain, or one is dilute the urine so it just carries itself down in the diluted water. And then the final avenue that we're really excited about is building scale nutrient recycling and water paired with water reuse. So this is another Brightwater Tools slide and product. The big red box encloses all of the different parts that we're working on to sell as a package. So I'll just actually talk about the flow here before we talk about the parts. So waterless urinals go in, directly drain with acidification or not, and that's a whole other thing that I won't get into. And vacuum flush toilets can also go to an anaerobic digester first, and then into the high strength wastewater tank. And then the freeze concentrator, it doesn't care if there's ammonia or nitrate or urea. all of those are concentratable, so there's no issues with ammonia loss like there is in RO or in distillation. So any of those forms are fine. It's pretty resilient there. Freeze concentration happens, then pasteurization happens, and then charcoal filtration. Although I'm actually pretty excited about the work with the MBRs and the powdered activated carbon that you all have been doing here. So that may down the road enter more into our planning as well. But for now, this is what we're envisioning, and so that produces a concentrated and sanitized fertilizer, and then a low strength effluent that can go out and combine with gray water from the building. And so the goal here, or the highest vision for how we think this could be used on site, is that all the gray water from the building, you can see on the right, the sink and the shower and whatnot, plus this effluent from the concentrator, are all low, and there's a very low nutrient load in all that. It could be treated and reused on site as reuse water, and then there's no effluent from the building. It doesn't have to be. It can be totally enclosed. Doesn't have to have a sewer connection. And in the United States, in some cities, it's a very high connection to the sewer because the sewers are overburdened, or they have issues that make taking new customers difficult and expensive. So you have to pay a lot to connect. And so there's this avenue to saving hundreds of thousands of dollars on the sewer connection fee by having a system that doesn't require a sewer connection. And so that's a place I think this could have a lot of value. Also in situations where it's discharged to the ground, it's discharged through a drain field, and there are nutrient limits, phosphorus or nitrogen, that just keeping those nutrients out of the gray water stream would let that gray water either be discharged directly or reused and eventually discharged. But take the nutrients out as a product rather than having to treat the water to try to eliminate them one by one in a non-usable form, get them concentrated form so they can become a product. And that product can have some value. We currently we're confident that product has a dollar value, but we don't really know what it is. There's a lot of estimates we've heard from different people all over the place. So we're really concentrating on the value as it's the wastewater treatment. We can quantify that better, and that's more the value proposition as a startup to our potential customers, our investors, is it handles wastewater better and it has the benefit of making a green product. But we don't really know what the economic value will be of that product. But I know that you all are working on that, so we're excited to hear what you learn about that as well. And then a closing thought that does definitely guide how we've approached this system, and what we focus on energy all the time, and on the physical material required to build the system, because my biggest concern is I don't want to chase this ideal of recycling resources out of human waste and throw all kinds of technology at it that take energy and consume resources to make a fertilizer that actually is worse for the planet because it took all those steps and all those resources to get there than just doing it the conventional way. So one thing that I'm really eager to do, and we haven't got the funding yet, but we keep pursuing it, is a life cycle analysis on at least a couple of versions of this sort of urine recycling, whether it's this one or one of the more simple ones, so we could start to be more confident. And there have been some. Stephen Hilton and others did a LCA a few years ago on urine diversion, but they didn't consider the infrastructure costs or infrastructure resources. And so I'd love to see that. And I guess that's the thing I really am curious to talk about with everyone I meet here, and as your research goes forward, is really understanding what resources are used and quantifying the value. And I think there may be some niches where the value goes beyond the calculus of energy saved on wastewater treatment and energy saved on fertilizer production. And there's other factors too, like there's all the resource extraction and all that. But the energy is what often I think it comes down to in conversation, is you save energy on both sides. But in some cases, like in Cape Cod with that sewer installation project, there's a huge amount of energy and expense in digging and in plastic pipes and the management of that sewer, and in economic cost. And I think that there may be sort of sheltered niches where there are factors at play beyond the sort of the generic urine collection treatment factors that apply anywhere that make it more appropriate there. Kind of like with solar panels, it was putting them on satellites was the niche that they were, I think, originally made for. And then it was, off the grid places that couldn't get power. And now we have it everywhere because it has been refined. But for early adoption, that's what we're looking for, is where are these niches? And I'd be really excited to hear if anyone has ideas about niches in Australia or elsewhere where this makes sense for ideas beyond the more generic theoretical reasons for urine diversion. So that is my presentation. We're at 10 o'clock, so I don't know how the organizers want to run this, if there's time for questions or if you want to move on at this point.
Any questions? Yes, please, Hadi, first.
Thank you very much. It's very, very fascinating.
Thank you.
Because you explain in simple words, I understood, I think, very well based on your talk. Question is related to human. You are using drugs, sometimes can be concentrated, especially for the contraception pills and other things, even for recycled water, they can detect. But how about using cows' urine or sheep, especially urine, in a large scale? Is it possible to use more cow's urine instead of human?
Mm-hmm. Yeah, so that question was, is it possible to use animal urine like cow or sheep urine as fertilizer? And it certainly is, and that's more practiced already because farms, well, not all farms, I guess a confined feeding operation where they bring in the grain, they just have to dispose of all of that. But in the farms in our area, they recycle that manure back onto the field. So that's more, I think, of a common practice, and absolutely works and is effective.
Okay, Stefan. Yeah, brilliant talk. Thank you so much. I just wanted to mention two things that we think might be a concern, but you haven't mentioned in your talk. So I'm wondering if you have looked into it. First is sodium. A lot of plants don't like that, and soils like it even less. Have you looked at what happens over time to the soils and whether you need to do something about it? And the second one is antimicrobial resistance. Although the paracetamol and the likes are not really getting into the carrot, could it be that bacteria that are exposed to antibiotics either during the storage of urine or in the soils over time lead to the development of antimicrobial resistance, which could then come back to us through the vegetable we consume?
Right, yeah, thank you. So the first one about salt, we have a very different climate, like I mentioned. So our precipitation far exceeds evaporation, and so we don't have buildup of salt in the outdoor, like in the exposed soils anywhere in the state of Vermont, because it's just constantly flushed through by the rain. So so that's a question that is not a concern of ours, but definitely has, comes up in more arid locations. I don't know what it's like here in the city. I don't know how that balance is, and you have salinity in this area, but I know that it's definitely an issue elsewhere in the continent. And the one brief, it was just really a back of the envelope calculations I did, so it's more just an idea of something to look at than a finding, is that that compared to irrigation water in irrigated land, the amount of salt added by irrigation was much higher generally, just from the salt in groundwater, than what was in the urine. And then what I wanted to pursue more, but I actually haven't, just because it's not pressing in our area, but is looking at synthetic fertilizers and what levels of salts are in those, because I know that is an issue as well. But no, I don't have any concrete answers for that. But I do believe that and this is more just an impression than anything else, but I think that there are a lot of things that add salt to farmland, and that urine is not, I don't believe that it is like vastly more than other factors, but that's actually, maybe I should have even said that. I'm not certain more of that than just like trying to skim through things and get an idea, because I just haven't focused on it. And then in terms of the antibiotic resistance, that is something that our partners at University of Michigan were looking into. I also know that there's been some more recent research on that, and our partners in Michigan, they had encouraging results that it did not look like many of those were able to carry through. But I don't remember the details of that, and I would recommend, if you wanted to look at that, Nancy Love is the author on all of those papers, and it's through University of Michigan. And if you look for antibiotic resistance genes, urine, and her name, I'm sure that you'd find the ones that I'm not remembering very well. But yeah, that's definitely on other people's minds, and I don't have a great answer for you.
Cara?
Thanks, Abraham. That's a really interesting talk. In comment with the cows and the sheep
Yeah.
urine, I'd like to see a cow train go in one of those toilets. That'd be utterly crazy. No. So I was really interested. A lot of the success, and particularly would have been really satisfying getting that news item through very recently about the Cape Cod.
Yes.
There's a lot of reliance on human behaviour and humans doing it right, collecting it right, using it right, treating it right, and so on. Have you had any regulatory pushback from that, or I can just imagine here in Australia, I just can't see them letting that go through. But yeah, I'd be really interested in your thoughts on that.
Did you mean in terms of like the jugs?
Yeah.
Right.
So kind of selling or letting individual households go and collect the jugs and so on, and then handling it themselves and having a little sign saying, well, just wait a month before you eat anything that you might have popped your wee on. And there is, I guess, some chance of cross contamination, fecal contamination. Or there's always some risk. It's never ever sterile.
Nothing's ever zero, right?
So I was just wondering how you kind of
Yeah.
relied on, or your sense of your confidence that humans are doing it right, because often they're the ones relying on them to do the right thing can be a bit.
Right. Yeah. That's a great question, and I guess the critical aspect there is that for the plum systems and the permitted ones, those we had to convince regulators that you should allow us to do this. But then on the other side, at some point, no one is regulating people who walk outside on their land and urinate onto the ground. And at what point does that become regulated? And our regulators in Vermont said, one of them basically said, one of the wastewater regulators said, I don't want to be regulating people with 5-gallon jugs of urine. Like, that's not a thing that I want to hear about or talk about or be regulating. I'll regulate the larger tanks. And what you do else, otherwise, that's not, I'm not looking at that. And then the person who does residuals management, he said, well, people using their own urine on their own land, that's not a residual from a wastewater treatment process, so that's not my job either. So basically, the people who oversee it said that's not my job, and so it's not regulated. Someone may come down at some point and say that is mine and I do want to regulate it, but that's why, as far as we can tell, it's legal because it isn't illegal. And in terms of how I feel about people using it, I think that there's a lot of more dangerous things we do than use urine as fertilizer, like we drive cars, and we make choices about what food we put in our bodies, and all kinds of things that affect our health directly, whether or not we exercise. And so if people are using their own urine in their own garden, it seems like a thing they're doing within their household. So it's thoughts. Yeah.
So due to time, okay, last.
Thank you, Sean, because Stefano stole my questions. Very interesting you talk. I'm responsible for the health risk modelling, so I'm really keen to connect with people in Michigan.
Great.
And I'm already working with the Michigan State Uni on this, so it'll be interesting. My question is, when you have people donating, do you give any advice around people who are sick and maybe with UTIs, that sort of thing, not donating at that point? Do you give advice around nothing?
No.
You're just relying on the pasteurization step,
Exactly.
which doesn't kill a lot of viruses, but we can talk about that.
Well, let's talk about it later. The state of Vermont thinks it does, and the EPA does. So I'm very curious to hear.
We're learning more about viruses now.
Okay, great. Well, I'd like to hear more about that. But yeah, the idea with the pasteurization is that it's accepted as treatment of wastewater in general, and that includes wastewater with a significant fecal component. So, so an E. coli is huge in feces. So,
Oh, yeah, E. coli bacteria, that's easy.
yeah, yeah. So, so with urinary tract infections, no, we don't have any recommendation on that because the treatment process is supposed to handle that.
Okay, thank you for your wonderful presentation, Abby.
Thank you.
So just want to update our AIC NiCE progress. So this is the realistic our target for the next couple of years, what we want to achieve from this project, and then how we can go for collaboration. So contents are what's the progress so far, and then research activities, how we can work together, what's the challenge we have at this moment, and then what's the next step we like to work together. So this is the summary of the progress so far we have, and successful outcome July, almost 2 years ago. Now is all project completed. So just a matter of we want to deliver our project, and then we had AIC Hub for the starting officially 31st July 2022. Sorry, not 2022, last year. And then we have actively engaged with the website, LinkedIn, and Twitter. Also, official launch was 17 November last year. So we had a discussion about what we have to work together and then how we can possibly collaborate. So that's the time. It's almost 10 months ago. So now we are meeting again to look at what we have done so far and then what we need support from our collaboration and then project. So that's what we want to achieve today. And then submit is just for our project, but tomorrow we have some of the circular economy for climate and environment conference. So this is a more broad range of the collaboration we can think about. And we submitted our AIC progress report in February, early this year. And then we collected all your performance KPIs and then necessary information and submitted the AIC. And then we got a successful outcome. Now it's time to have another progress report. AIC requests every 6 months report. So already you know that your publication was media communication or some conference, workshop, everything will count. So if you have any KPI for next couple of weeks, Ibrahim will contact you to update your KPI and what you have done. So please provide, and then we can continue for our good progress of the AIC. Also, we had a strategic meeting early this year. So Dana Kodeshi organized this meeting, and then we published very recently for our strategic meeting 2023 to 2026 for next couple of years, what we have to do. So we have identified 3 things. First one is what's our value chain. So we need more end users, application to verify our fertilizer. So already, you know that the Research Institute, they commercialized their urine fertilizer, but still we are under investigation and research purpose. So for next couple of years, how we can achieve the value chain. So end user application, that's the one our themes. And the second theme is the people and policies. So we need to follow a lot of guidelines and regulations, so how we can achieve from this kind of EPA approval, also government approval processes. So that's what we have to also connect with the government people to get this kind of fertilizer approval. So it takes time. So that's the second theme, people and policies. The last one is the technology and innovation. Still, we have a technology already. He introduced the pasteurization, very simple way, just 80 degree and then 90 seconds. The urine will pasteurize and then you can utilize as it is. So it looks like a very cost-effective and simple way to apply the urine fertilizer. But we are currently utilizing our building level of the membrane bioreactor, also distillation process, electrodialysis process. Also, some people are using just the biocarrier biological treatment process. So how we can make a more cost-effective the technology and innovation to convert urine to fertilizer. Also, we have a lot of struvite crystal, how we can make this kind of fertilizer usable, also liquid fertilizer. So there are many ways that we need to break through for innovation and then this technology. So three things. So I just want to emphasize again, value chain. Second, people and policies. Last one is the technology and innovation. So this is our strategy for next couple of years. If you can contribute one of them, that will be very much appreciated. We can work together and support each other. And we have produced brochures. So Matthew is there from the urban utility. So he initiated this brochure. It's very professional. Looks like Lithuania in a circular economy, Brisbane node. So we have three nodes: Brisbane, Sydney, Melbourne. So they have a different technology. And then we have produced this brochure. So the next tomorrow and then the day after tomorrow. So we have a AS NiCE booth. So you can come and visit. So you can see the brochure for the very good quality of the hard copy. Also, you can see our different fertilizer, and also we can share some of the material for what's the progress of our technology. And that's the Brisbane node we have. So if you need the PDF, please, this is the public, so you can also utilize for your presentation or for your research or commercial opportunity. So this is the Brisbane node. They are planning to apply for their application to the Victoria Park for the public toilet. So detail will be announced by the Matthew and then the Stefano will present today. So this is the cost of growth, and then that's they are looking at the public toilet for urine diversion system, how we can collect the urine in the park. And this is how they want to apply and communication engagement, also project timeline. So by 2024, 2026, so they want to verify all the necessary pilot and then approval, also regulation, to apply for urine diversion system to fertilizer near the parkland. So that's the Brisbane node. Also, we have Sydney node for the building level. So you are in our urine diversion building level. So if you urinate from the toilet, especially men's toilet, not the female one. So you have we collect all your urine, the basement. So from level to level 12, so we have 3 male urinal, and then we collect all the urine to the basement. So if you are interested, yeah, we will organize the visit to the basement. Also, we have our membrane bioreactor system, how we are converting from our urine to fertilizer. So you can see the technology. So please, if you want to see it, so at the end of the day, so we have some dinner time together. So after dinner, we can go for our pilot unit. So you can stay here. then we can try to show you. And we have also Melbourne node, so southeast water. So Lee Gao, he will present today with me, and then he will make the portable, like a caravan system of the urine collection. And then they want to collect the urine from the public area, like a music festival or fireworks, and then people come and then they can put their caravan. Then we installed our ambient system inside the caravan. So you have a female, male toilet, and then you collect the urine directly, and then we convert in the caravan system, and then apply our fertilizer directly. So this ambient system has been designed together with the origin water. So we have Jing is here. So we have a pilot scale in the upstairs. So if you are interested, our pilot ambient system is ready to demonstrate. So you can see in the level 12. Also, we have newsletters. So thank you to Jade and Ibram and Wanjang. So they have published 2 newsletters. And recently, for this month, September, so we have a newsletter to cover all the strategic meeting report, also visitor from the commercial or some non-commercial organization. Also, we like to advertise more industry because you have a lot of progress of your project. So industry partners also we can promote to your industry. So please join this newsletter, and then we can keep engaging for our project as well as industry engagement. So please give us information, we can keep updating. And this is the newsletters September. So you can see the Western Sydney University, Jeff is here. So they are progressing a lot of the plant growth comparing with our fertilizer. Also Melbourne University, they have connected with the very simple male urinary toilet in the university, and then they are doing a lot of experiment together with the postdoc and PhD student. Also we have a NiCE hub, social media. So social media cover a lot of information what we are handling here. So if you want to share any information related to our project, also your company, also your development, so please let us know, and then we can also keep uploading your information here. And thank you again. So we have 7 universities and 22 industry partners, and then 3 international organizations. And this is the NiCE law progress. So Melbourne node. So we want to achieve this caravan system together with our urine converting system together. And this is our fertilizer comparison. So hydroponic, and then Aurin from European was our fertilizer first generation 3 years ago, and then second generation of the oval fertilizer. And Ugold is from Brisbane node, so they have electrodialysis technology. And then very recently we have collected the third generation. The first generation, second generation, third generation means every year we collect the urine from our university, and then we mix together, and then we measure this fertilizer. So you can see the first generation ratio of the NPK, so 10 to 0.8 to 2.9. The second generation 10 to 0.4, 3.5, and then very recently 10 to 1.4 to 6.8 NPK ratio of the fertilizer, which we have a very suitable NPK ratio to grow the plant. So we are testing also different plants. So we will have a lot of application in the afternoon presentation from the Royal Botanic Garden. And what's the future activities? So we are planning to have fertilizer registration exemption from New South Wales and your state's EPA. also certification and safety data set and labeling of the fertilizer, and then try to commercialize this fertilizer. So when we provide your fertilizer bottle during the launch, at the time we didn't have a spray time, so a lot of people gave a feedback. Now is we have a, I don't want to push this one. Yeah? Sometimes it can be used as a weapon, so you can use it as a fertilizer, as a weapon for just emergency situation. So it can be more comfortable rather than just utilize your cup. So it already improved a lot. Also, do you have any feedback for your plants? So we gave you this toilet plant. It's just 10 months ago. So how many people still grow well? Okay, 1, 2, yeah. Looks like most of them, they are taking care of very well. So if you need more fertilizer, so please let us know. Also, some of them, like we provide a cactus type of the plant, also this type of plant. So it looks like cactus, it died from my experiment. So some of them, I don't know, if you can take a photo, so if you can show like which kind of plant type, so we can decide this kind of toilet plant, we can targeting on this kind of plant which survive very well. So we can also keep providing this toilet plant in the future. Also demonstrate long-term applications. So we have already technology, and then we have already everything is ready. So how we can go for the long-term application, we prioritize the stakeholders and distillation impact, and then NiCE mobile toilet will be ready next year, and then support 3 nodes, Melbourne, Sydney, and Brisbane will be also very actively scale up for next 2 years. So we want to support this demonstration, also public education acceptance. We will continue to educate our communities. So what's the next is, okay, OG Water will be held in Melbourne next year, April 31st and early May. So we want to organize the workshop. So Melbourne North, Southeast Water can drive this workshop was together with the Melbourne University. So we can demonstrate our caravan system and then our NiCE hub. So if you can join, do you have any plan to join the OG Water next year, 2024, early May? So we can please send the email. Send the email. We have a Melbourne people here. So please send the email. We can organize workshop, and then we can just present our own project to explore outside people. Also, we can demonstrate possibly our caravan to show this fertilizer. So that's the good communication engagement we can achieve. So if you are planning to join our OG Water 2024, so please let us know. Then we can organize the workshop, and then you can have a presentation. Also, we can engage together. Hopefully, we can get the registration fee discount. So that's the main point. We would like to have some of the workshop together. Also, PhD student array. Also, yeah, please let us know if you need advertisement and promotion. Yeah, we can help you out. And regular meetings. So far, we haven't done a lot of engagement with industry committee members, scientific committee members. So we can also engage some of them. So if you're interested, we can help you to work together with our industry and scientific committee members. And we can have a progress report for next couple of weeks. Please give us your KPI. That will be very appreciated. Also, next first NiCE Summit will be held in 30 September 2024, and then SESE Conference 2024 also held in 1st and 2nd October. So you can just pencil your schedule, and then we can have a more active engagement together. So thank you again for our students and collaborate. Also, very appreciate industry support. Without your support, it would have been happen for this project. Also, all the international collaboration. Thank you again, and the ARC for their generous funding. Thank you for your support. So before we go next session of the urine collection from Kara, do you have any question for in general progress of the ARC NiCE Hub? Yeah.
Sean, I was just going to ask about the communication platform. Whenever I come to these events, there's so much rich information to share, but I still don't think we have optimised the sharing of information across the researchers. We can put up a paper we've published, but there's all the unpublished stuff and the discussions and discussion forums, and I think we haven't quite nailed that yet.
All right, that's a good idea. Yeah, we will definitely consider this factor. In fact, during the CES conference, Aldo will organize a very similar workshop for the engagement nutrient supply economy. Also, a lot of poster presentation. Definitely, we will also have a more
Offline.
engagement kind of public communications. So we have a first session will be chaired by the Kara Bill.
Thank you. Good morning, everyone. My name's Cara. I'm from the Sedis Research Institute at Griffith University. I'm one of the researchers, one of the Griffith researchers in the NiCE Hub. You'll hear from a couple of them today. While Stefano's organising himself, so it's International Week of Happiness at Work. So I think this is a wonderful way to start the week, networking and coming together and talking all things we. And thank you again, Abraham, for a wonderful keynote. I've got lots of questions I'll corner you pretty soon. So I'd like to acknowledge the Gadigal people of the Eora Nation, the lands that we are meeting on today. We're from Brisbane, so we're generally in the Turrbal or Yurugal nations as well up there in Meanjin. And of course, even though we're talking nutrient and systems and circular economy, we kind of have to sort of start somewhere, I suppose. And this session's about where we might start in actually collecting the urine, which raises lots of different issues. So we've got some great speakers today. And the first one is Stefano Fragoya and Ligao. Ligao's from South East Water, Stefano's University of Melbourne, and you're also the co-director of the NiCE Hub, aren't you?
Deputy.
Deputy.
Yeah.
Yes, deputy. And you're going to be talking about downstream effects of urine and its conversion to liquid fertilisers. So please welcome Stefano and Lee.
Thanks, Stella. It's great to be here. And I'm not coming along. So Ligao from Southeast Water, our main industry partner, and my PhD student Chen here, because obviously I will just need his help on some of the items here, so he knows the stuff better than me. So it's great to be here, and this talk is really not linked to one of the three nodes. It's more broad nature. So Abraham mentioned how he found fertile ground in Vermont for urine collection and treatment. In Australia, we've been focusing on cities more than rural areas. So when we look at Australian cities, we already have sewers. And so one of the questions that came up from the beginning is what happens when you take urine out of sewers to the sewer and the sewage treatment plant downstream. So we have been looking at this for quite some time, in fact, and the idea is that urine contains the majority of the nutrients. We know that, NPK, but also sulfur, 70% of the sulfur, and sulfur is what causes sewer corrosion. So we're looking into that, particularly looking at this right-hand side box, the problems with current sewage system. In Australia, sewage systems are coming to age. they're facing replacement or upgrades. And so what's the smartest thing we can do when we now have the opportunity to work with reduced nutrient loads into our sewer system? So what we are looking at in this project is two separate lines. First is these downstream effects of taking urine out of sewers, and second, together with Southeast Water, we wanted to look at yet another technology. So we're really technology focused. We want to be comprehensive in the NiCE hub, and so we're looking at membrane distillation coupled with MBR. We're looking at electrodialysis or microbially boosted electrodialysis in the Brisbane node. We kind of needed to look at RO as well. So this is what they're looking at in South Africa and in the US. So we wanted to have our spin onto the RO story, and that's why we're looking at it as part of this project. So two sides of the story, looking at downstream effects of urine separation, and two, RO for urine concentration. So this actually started with urban utilities before NiCE, when we were really interested in kind of estimating what are the effects of this urine separation. So we modeled it. So we modeled it with the Keshab, Sharma, and UQ using a well-established sewer model. And the model told us if you take 75% of the urine out, you will actually experience a slightly decreased sewer corrosion, but not major. But when we look at sewage treatment plants, the model told us if you need to upgrade these treatment plants from where we are at now to an increased capacity, what the cost of these upgrades is going to be greatly diminished if we are diverting out a fraction of the urine. So this is just one of the graphs that we have in a paper published in the Journal of Hazardous Material together with our industry partners. And it shows, for example, if you look at the middle column in the graph on the right hand side, that if we're going from a 1 million to 1.5 million equivalent population size upgrade, the cost of that upgrade is going to go down from $130 million to about $30 million because of the benefits, the reduced size of the bioreactors and the reduced energy consumption that goes into treatment. So this is pretty major, and this leads into that value chain that we have been talking about. What can we actually use as the value proposition? It's exactly what Abraham was talking about, but in this case applied to a large city with a developed sewer system. But the question was, are we happy with the model? Of course not. Model is hugely simplified and sewage is highly complex. So we don't really fully trust it, or we do trust it, but we want to validate it. So we're going to validate it both in the lab and in the field. It's going to be really hard to do it in the field, but I'll show you in a minute how we plan to do it. So SBR setup. This is what Chen set up in the lab to simulate a sewage treatment plant with a sequencing batch reactor with a few different stages. So you load it up, you have anoxic and aerobic, cycle a few times, and then you have a settling phase and a decant. So basically in one vessel, what happens in a sewage treatment plant. And we want to feed this system with stuff that looks like sewage. We can't really use real sewage because then we don't know how to take the urine out. We don't really have sewage that is being created without urine, because although we have waterless urinals and urine diverting toilets, they all discharge into sewers that already have a flow going. So Chen came up with some formulas to create his own sewage, and the influent here shows chemical oxygen demand, suspended solid, ammonia. Can you tell us a bit about what you put in there to make it look like real sewage, Chen?
So basically, we know that our sewage contains grey water, urines, and brown water. So our sewage was formulated and manufactured based on this formula. For example, like 74% grey water, 24% of brown water, and 1% of urine. So for the table that show here is the performance SPR that cultivate without urine diversion. So after the conference and summit, we will start the urine diversion and we will observe the impact of urine diversion to the performance SPR. So how we do this is we will gradually reduce the composition of urine. For example, we know that 1% of urine in our sewage, so we reduce to 0.75%, 0.55%, 0.25%, and totally no urine. So we will observe the performance of SPR.
Thank you, Chen. The other thing that Chen is planning to do is to build a simulated sewer pipe in the lab to load it with the same stuff based on synthetic ingredients and see what happens in the sewer, where we expect to observe a decreased amount of hydrogen sulfide in the headspace of gravity sewers, and we expect a decreased formation of hydrogen sulfide in the rising main based on the modeling. But what we know is that also the pH gets affected, and there's cascading effects that are not so clear. We might have less fermentation happening, we may have less conversion of slowly biodegradable to readily biodegradable COD. So the influence of a treatment plant might look really different, and it might not work the same way as it does today. So that's what we plan to look at in this objective, which is going to happen a little bit later. Maybe it will get started by the next NiCE summit. So, Lee, how are we going to look at this exact problem in a real sewer system? So, with real sewage. Actually, what we have is the perfect opportunity in Melbourne to do this. So we have a new campus coming up in Fisherman's Bend, and this campus is going to be completed in 2026, and with a lot of effort we managed to almost convince the developers and our leadership in the university to include urine diversion in one building. This full building will also be serviced by its own small sewage treatment plant based on MBR and RO. This will enable a lot of research opportunities, but this will also become the first place in the world, I believe, where we could test the effect of urine diversion on sewage treatment, because this whole building will be serviced by its own little sewage treatment plant. So if you want to join us to do any testing of how a sewage treatment system forms in a urine diverted system, this is going to be the place to do it. But it's going to be legacy of NiCE, because it's going to be started after the end of NiCE. But this also helps us to look optimistically into the future. This idea is not going to be over at the end of NiCE. It's going to be commercial technologies, commercial fertilizers, and this place that we can use for many years to come to do more testing. So we're kind of running out of time, but I want to show also this reverse osmosis. Actually, Lee, would you want to talk about your involvement in Southeast Water's involvement in Fisherman's Bend? So Fisherman's Bend, actually, this new campus falls within the catchment of Southeast Water.
I guess just very briefly mention about our involvement. Like Stefano already mentioned, the two key components of the project is about the downstream impacts for the urine separation, and secondly is about new technology to recover the nutrients or recover the resources from the urine. So basically we get this, we call once in a generation opportunity to implement it at Fisherman Bend. Just a bit background of Fisherman Bend. Fisherman Bend is an area of more than 480 hectares, just right to the city center of Melbourne. And this is the biggest urban redevelopment in Australia. And we have 5 precincts with education precincts, industry precincts, and residential precincts. And like Stefan already mentioned, we will have Melbourne Uni's new campus here. So we are going to implement a lot of new innovations, integrated water management approach, resource recovery, circular economy method, try to bring the new innovations to our customers and build the most available communities here. So that's probably, I guess, one quick mention. Thank you.
Thanks, Lee. So for the RO system in the lab, so this slide shows that we put raw hydrolyzed urine in. So most people use acidification or use fresh urine. You use hydrolyzed urine to be different, and also because that's the easiest thing you can get, because urine hydrolyzes almost instantly. And we managed to get, as expected, very good recoveries of NPK, with N being the worst because it goes through the RO membrane to some extent. So this technology is pretty good for phosphorus recovery and concentration up to a factor of 4 times. So high pK recovery, low energy consumption estimated only at this stage, about 1 kWh per kilogram nitrogen. We need to always keep energy in mind. What we found was minimal biofouling. I initially wrote no biofouling, that Chen corrected me, said we put minimal because we did find some cells there, but pretty much the membrane looks like a clean slate. And that's because ammonia is biocidal. Actually, ammonia is used to clean our membranes. So we actually don't need to do any cleaning because it happens by itself. Although we have a little bit of inorganic scaling, and that still causes a flux decrease, but that's readily reversed with a bit of an acid wash. And then the other thing, we're inability to separate nutrients from micropollutants. We're learning today that that might not be an issue, which is really good news. So, if that's the case, then we don't need any pretreatment. But if we do need pretreatment, we'll be prepared to implement one. In fact, because I brought up the question of sodium before, do you know what happens to the sodium here? Does it go through the membrane just like P&K, or?
No, the sodium will be recirculated and retained in the retentive. So the sodium concentration will be pretty high in our case.
Okay, so sodium remains a problem. Okay, so this might go into the NiCE loo if we feel that it's going to be good enough. Thank you.
Just lurking.
It's, we pull out, finished. So thanks for your attention.
Thank you, Stefano and G and Lee. We're waiting for questions after the session, so there'll be 2 more presentations around 10 minutes, and then we can hold on to your questions, write some notes, and then we can have a bit of a Q&A session afterward. So thank you very much. Thank you very much for that. Very interesting. The next speaker we have. Do you know how to get this on? Is Bezad Fatahi and Jeff C. Bezad is from the University of Technology, Sydney, and Jeff C. is EIC, but I'm not sure what EIC stands for. It's fine. No worries. All right. And you will be talking about the novel sustainable ground stabilisation and calcium carbonate precipitation of urine. Thank you, Bezad.
Good morning, everyone, and thanks for giving the opportunity to present this research. I've got my colleagues, Hadi, who's here, raise your hand, Hadi, and Niti is a new PhD student we got. So they have been contributing to this project. So CIMIC and EIC, they are infrastructure projects, like infrastructure builders and contractors and designers. So basically we are working on utilizing the urine to stabilize our roads, airports, and so on. So it's a bit different to the rest of the fertilizer story. So I will give you a bit of introduction, what problems we have, what are the current solutions, and what's our proposal, and the plan of the testing that we are doing in this project. So what I guess we understand is that because of the increase in the population and also running out of the good lands, many of our infrastructure, including rail, road, and so on, are built on low quality ground. And one of the major issues here in New South Wales is old closed landfills. So there are a lot of old closed landfills that they used to be out of town, but because of expansion now they are part of the cities. And these two examples that you see here, they are here in Sydney. So one not very close, not very far from here, and one in the western part of Sydney, that they are building road and a lot of bridges and so on, and the other one, the railway station there, an interchange. So, and obviously when you build on top of these types of ground, so there will be a lot of settlement, so airport or road or railway pavements and so on, they will crack. So there are techniques we like to improve them. And of course there are other types of problematic grounds, including soft soils. I'm not going to dive too much into these ones. I guess if it's muddy land, it will settle as well. If you have got a loose sandy material, similar you have got under the, close to the beach, I guess. So again, if it's under the ground, the buildings and roads and so on will settle. Same for expansive soils, that when there is a rain or a lot of water getting there, it will expand. That's why many buildings, particularly new buildings, they have got a lot of cracks on the walls, and same applies for the roads. And this particular issue of the expansive soil is very popular. So the soil that when you add water to it, it expands. It means your foundation of your road or building keeps going up and down. So that's why you get a lot of cracks on the structures. The current techniques to improve the landfill and also those problematic soils typically is using some materials to stabilize the ground. The most popular one is cement and also lime, so that they add them to the ground, as you can see here, mix them, so it becomes a stabilized ground. So it becomes much stiffer, you can build your structure on top. So the issue of construction with cement, I guess everyone knows that cement production creates a lot of CO2. 8% of the world carbon dioxide is because of production of the cement. So after water, concrete is the most used material in the world. So therefore a lot of cement goes there. And I won't again go too much detail, but the whole process of cleaning and converting the clay and lime into the cement is very energy intensive. So the idea that we have in this project is that for different types of materials, let's say for landfill, that's what we are starting, that NiCE is working on at the moment. So what we're gonna do is that we're gonna get the urine, but it should not be hydrolyzed urine. So what was mentioned earlier, because we need to recover urea, I will quickly explain. And then we're gonna collect it from this building. We're gonna increase the pH at the moment, so to make sure the hydrolyzing won't happen. So then we will follow two passes, one using addition of the some food for the bacteria that exist in the soil or in the landfill. We're gonna stimulate the bacteria, increase the concentration of the bacteria in the soil. Then we're gonna add the urine, so it will then consume the urea and convert it to basically bicarbonate. And in addition to that, we will add a calcium, so therefore bicarbonate, which is not what I guess most of you are not interested about, the bicarbonate, because it's not a fertilizer, but then we will add a calcium to it, it will form a natural cement, and basically it will become stronger. So that's what we will be doing. So the other opportunity that we will explore is addition of enzyme, rather than adding a food for bacteria, that bacteria will create the enzyme, we directly add the enzyme. So this shortens it, but then cementation happens very fast. Of course, it comes with a cost consequence if you need to add enzyme, which is more expensive than yeast, for example, which is for the food of the bacteria. The mechanism involved, as you can see in here, is that first, by addition of urease inside the soil, not outside, that's why initially should not hydrolyze, you will create the bicarbonate plus ammonia and so on, that we don't need them, that's the problem, the ammonia for us, I guess. Then we will add extra calcium to it, and it will react with the bicarbonate and then form the cement or lime, you can say. It will be precipitated inside the soil and bind the particles together, as you can see in this picture. So these are not bond particles, but here cement will be surrounding this. So therefore it will bind the particles together, it will become stiffer. May not be necessarily good obviously for the farming, but it is good for the infrastructure projects. So the process in here, that's what I explained. So you will have the urea, and then you're using urease. You will create a bicarbonate plus ammonia and ammonium, and then you will add the calcium and you will get there. And of course we have to keep the pH high or very low. Let's say we are looking at keeping it very high to make sure the hydrolyzing won't happen, and it only happens inside the soil when we want. So the current plan there is that it will be collected, the urine will be collected from this building that Sean is organizing the visit for us later. Then we will measure we will stabilize this urine by adding the calcium hydroxide into this. So therefore the pH will go up, so it won't hydrolyze. Then what we will do is that we measure the urea content in there, and then we will filter this whole thing to make sure we just, what are the sedimented there, like such as phosphate and so on comes out of this. And then we will reduce the pH, and now we will have two liquids in there. One, we will add the extra yeast to it, which is a food for bacteria that exist in the soil or landfill. We are starting with landfill. You imagine how dirty it is, but it is on the construction sites as it is. And then we will basically increase the number of bacteria in the soil by giving this food. Then when this process finishes, through another channel, we add this urine plus the calcium chloride or calcium hydroxide. Both of them can be used as the mechanism to cause the cementation, and bacteria is in there to basically break this urea into the calcium carbonate that we need. And the test we will be doing this one is one of the tests that we will push the liquid through the soil, as you can see, and then we collect it on top. So by doing it several cycles, we can keep increasing the amount of cementation that happens in the soil. So usually one cycle won't do it. We need more deposition of the cementation there to make it stronger. So, and this is a list of tests we will do. So the base materials we will use. First one is the landfill material we have collected from one of the construction sites here in inner west of Sydney. Also, we will collect some Bringelly shale from the new airport being built in western part of Sydney for stabilizing the runways. And also we will do a test on the sand as a benchmark. And the materials or additives for the treatment, of course, will be treated urine plus lime and cement as the benchmark to see relative to those ones how good they are. And these are the bunch of tests that you can see. Typically they are the mechanical tests to measure strength and stiffness of the material we have. So one of the issues there is creation of the ammonia byproducts there, which is not nice obviously for us. So we will explore a few avenues, addition of natural zeolite, basically to remove the ammonia, or we will try to immobilize it, means it's there but it won't move, or we will do a simple drying process basically to get rid of ammonia on site. So here we are talking about areas of tens of kilometers or hundreds of kilometers. So basically these are large projects. And of course, maybe that ammonia can be collected for hydrogen generation and so on. So and the benefits will be reduction in the CO2 through the reduction in the use of the cement or general purpose cement. And in many developing countries or underdeveloped countries, actually the cement is not there. So even if they want to use it, they don't have access to it. But they have access to the actual urine there. And of course, this will also improve the image of the construction industry, which is not that great, I guess, in terms of CO2 emission. And the project will address also sustainable development goals of the United Nations, as you can see, from infrastructure reducing inequalities, sustainable cities, and so on that you can see. So thank you very much, and that's the, oh yes, sorry, I have still one more slide. So what are the possibilities for collaboration for us? I would like to really explore these opportunities. One possibility there, if you can think of something, is that if we can have access to a concentrate of urea, which is not hydrolyzed, this will definitely help us to, rather than using several cycles of treatment, we use one cycle. So if some of you work on the concentrate of urea, we are so keen to see how can we get that. Of course, on use of other stimulation solutions or the food for bacteria, we like to work, minimizing generation of ammonia, and of course using other types of materials for improvement. But the first one, what I just have identified is this urea concentration. If there is someone working there, I'd like to hear more. And thank you very much for listening to me today.
Thank you very much, Lisa. That looks quite novel. Has anyone else been doing this?
Not for soil quite.
Okay,
Yes.
good
There is a
stuff.
bio break, you might have heard. They made a break, but not
Yeah,
to this scale for sure.
and it's great to see the SDGs in there, because this is what we're doing all this for, I guess, is to work on those SDGs and making it more livable and safe generally. So the next speaker we have, the final speaker in our little session, is Associate Professor Saad Iftikhar, and he's a colleague of mine at Griffith University, and he'll be talking about the whole of system economics and generally how it's mentioned a couple of times today, the technology is great, but is it financially viable, and what other factors do we need to consider for making this a feasible project? So, all yours, Saad. Thank you.
Thank you, Kara, and welcome everyone. Right before the morning tea, so I'm quite conscious that you might be feeling hungry and a bit tired. Okay, so let's get going. So today I'm going to talk about one component of the whole project, which is looking at how do we evaluate, how do we develop a value proposition and business case for these kind of technologies and products and systems. So if you have seen the NiCE brochure, you have seen a picture like this, where we are trying to capture the circularity or the flow of systems and products from one system to another. And then what we have here is that we have urine diverting technologies and products, right? And what ultimately, and already Abraham has in his very nice talk, he has outlined quite a number of benefits, as well as Stefano and Bejar. So what we can see from here is that we have major types of benefits, for example, reduced leaching and runoff, which has an impact on the environment. And as well as we start to producing or expecting the fertilizers, and that also has an impact on the productivity in terms of agriculture and food production. Where we are coming from here is that there is an additional benefit, which is around the sustainability, security, water security, and people security concern. And that's where we have these other broader type of objectives. So the question or challenge for our small team is that how do we bring all these things together, especially when we try to convey the business case or the value of this kind of investing in these kind of projects. The challenge here is that when we are talking about environmental benefits, we have lots of non-market intangible benefits where these are quite highly in abstract sense, and we talk, people understand, but we cannot show it on a paper, right? So that's a challenge. Okay, then other thing is that when you're talking about food and fertilizer, yes, we have some market benefit. We can look at fertilizer price and then, okay, this is the kind of approximate benefit. But then how do we capture the sustainability concerns, for example, in a business case or in dollar values, which probably will be more convincing to decision makers? Because ultimately what we want to show is that whether it's economically, financially, socially viable or not, because that's ultimately our decision makers want to know, because that's where they invest, whether it's worthwhile to invest in this project or this type of projects or not. So we have two broad objectives within the component within this project. One is the demand and value assessment, and we will particularly focus on non-market value part, because that's where there is very limited information to understand people's preferences and values of these type of systems. And then we also develop business cases, especially for the selected case studies, based on the available data to see at least that when you develop a formal, put everything in a formal cost-benefit analysis, whether it stacks up or not. And if it's not, or if it is, then what are the sensitive parameters that we need to be more aware of. So given these broad two objectives, what we can think of is that a kind of a cost-benefit analysis framework, which is a very standardized method, with standardized technique. People, regulators love it, they use it. Even if they do not use it, they talk about it, okay? So that's quite important for us to consider. So usually when we have this kind of cost-benefit analysis framework, we have to start with and without the project, right? So without what is going to happen if it's a baseline status quo scenario versus if we have these kind of technologies in place. So the kind of information that we will need as part of our project as well is to understand the physical impacts, right? The physical benefits of these kind of projects, which already Stefan and others, they have shown some from their pilot case studies and experiments. So when we talk about physical changes, we also have to consider who are the relevant stakeholders, who are going to get benefit from it, right? And then on the other hand, we have to actually invest in this project, install this project, so that means there are activities, physical inputs, and that would require current and future work. One thing I pretty much like from Abraham's talk is that when he was highlighting the adaptation options, the community acceptance, and that's actually a critical element of this whole project, because we already have seen with wastewater here is that yuck factor, right? So you could already know that. So this is going to be also an issue in our case, so we have to think of the adaptations, adoptions, and risk, as well as who are the relevant stakeholders, right? Who is going to share the benefits, who is going to share the cost. So all these things we have to consider as part of our overall business case or economic analysis. So the challenging part is to evaluate and calculate the non-market values of these aspects, so that's why we have an emphasis on the non-market part. But cost and the market aspect, they are also equally important, so we cannot ignore them. So we do put them together, and that ultimately gives us an indication of the overall economic efficiency, which includes the net benefit cost ratios, and we also would look at stakeholder level efficiency analysis, for example, stakeholder level net benefits and cost benefit cost ratios, as well as I have said, the sensitivity analysis part, right? So which assumptions influences our decisions. So that's the broad thing. That's what we will hope to produce as we go along through the project, as we develop our case studies and get more and more data. So one thing we already have more or less completed is Gam, who is a PhD student. If you could please raise your hand. So she already has done a systematic literature review on the kind of papers which have conducted some sort of economic or financial analysis of these systems. And so from her findings, and she has a poster which she will be presenting during the conferences, but please feel free to talk to her. One of the things that we were interested to know that what's the overall understanding of these different factors and what drives supply, demand, and economic feasibility of these products and technologies. Okay, and then we stay particularly interested to know what people have found or reported in terms of economic feasibility or economic performance. So through the systematic literature review, actually ultimately we were able to find only around 64 studies. So there are not many studies which have reported or looked into this aspect, which is a good thing for us as well as a bit scary, right? So if there is not much information, why not? Anyway, so what basically we can summarize and is that it's like more or less it's driven from experimental approach. In some sense, it's like the supply side, that where people are like researchers and other entrepreneurs, they are interested in the technical feasibility and performance of these kind of systems. So it's like an experimentation stage. So then we have to bring in the regulations, especially if we want to have pilots, if we want to go for demonstration site, etc. And ultimately, when you go to the commercialization stage, then we have to talk about financial benefits to the proponents or to the businesses. So then we have to look at the other side, which is the demand side. Okay, so in the demand side, there have been some studies which they have looked at in particular in a hypothetical stage, like okay, whether in some cases they also looked at real case studies. What they have found is the community attitude and social acceptance is a big factor, right? right? And as I mentioned, we industrially we are familiar with this. Cost savings, or whether it's actually beneficial to the household or beneficial to the businesses, that also have come up as a quite important factor. And finally, how well the system is performing, especially in relation to the environmental performance. That has come up as a factor. So overall, we are interested to look in this systematic review is what factors influence both supply and the demand side of these systems, and whether does it influence, and what do we know about the economic performance of these systems. Unfortunately, out of 64, only 18 have reported some kind of economic analysis. In many cases, they have reported payment period, some cases they have reported just the cost of achieving a target. What we are trying to achieve here is that comprehensive cost-benefit analysis, or which allow us to understand the net benefit of this project. That's actually pretty rare. Okay, and the results are quite mixed. And what we have found is that incorporating the non-market or the dollar values of the environmental concerns is a significant factor in tilting the curve. So I think we are in a nice space, good space, unlike nice and nice. But because we have a dedicated objective of evaluating these non-market values part. So hopefully we'll get some good outcomes. But that's it for the moment. So we are in the data collection and desktop synthesis. So we'll start with, after submitting the systematic review, we'll start looking at the market data and start looking at desktop analysis. And there you'll hear from us regarding organizing workshops and to get the data, whatever you have, and then finally we'll design non-market surveys to get primary data. Thank you very much.
Thank you very much, Simon. Very nice time.
You understand?
Yeah, so we're actually, we're now ahead. Well, morning tea is until 11:30 and it's 10 past, so we do have some time for questions for all three of the presenters. I'm not sure whether you want to stand up or so. Just to remind you, there was hands up. So there was Stefano and team. There was Besad and team and Syed as well. And just while you're thinking about your questions, and will be second, I just wanted to let you know that at 3:10 this afternoon there will be afternoon tea with action. And if you look over the page, because we'll be ready for a bit of action then, we've got Aldo Ameti here from Griffith University as well, and we'll be getting your ideas, the experts in the room's ideas, when you would have seen everyone's presentations today, from collection to treatment to end use and so on, everyone's ideas of what might be drivers, what might be barriers to actually operationalising and really scaling up urine collection and diversion and reuse. So get ready for afternoon tea with action later on today. Let's start with the first question, please.
Hi, my name's Jordan. I work at the Resource Stewardship team at ISF, at the Institute for Sustainable Futures, and I'm also about to take a PhD with the NiCE program. In regards to the CBA that you're going to be undertaking, I'm just wondering, one of the issues with CBAs is capturing the environmental and social externalities and measuring those. So I'm wondering what kind of methodology you're using in regards to that. We did a project recently with the Queensland Department of Environment and Science. We looked at the a cost-benefit analysis that was done of their container deposit scheme, and we kind of came up with a framework. So it'd be interesting to kind of share that knowledge. But I'm just kind of wondering how you're looking to tackle kind of measuring those externalities.
That's a very nice question, and happy to hear about your framework. We'll be definitely talking to you regarding the kind of we are more interested in the people's social preferences and social values, and that's where we will be trying to capture the non-market aspects of these projects. And that there are standard techniques like survey-based techniques as well as market analysis data that we'll be able to use. Regarding the physical impact or physical externality impacts of these projects, if there is, that for those we have to rely on the other teams like who will be collecting those data. Yes, but the social aspects, that's what we will be using primary data collection based method. Yeah.
Sorry, I have one more question for the gentleman about soil. I'll hijack. In regards to the sustainable soil stabilisation, I'm not quite sure you're looking at general kind of cement, but realising that a lot of cements in the future, it seems like the construction industry is becoming the dumping site, you know, whacking in tyres, plastics into our cement to reduce GHG emissions. How are you looking at how those kind of different cements are going to impact your project as well? If you are, I'm not sure.
Sure. I think this is just one alternative we are creating. So addition of other waste products like rubbers and so on, it is there, but doesn't necessarily increase the strength. It may add extra benefits for damping and so on. That's the addition of rubber. But this one is a solid way, and most of, I mean, because it creates a cement, I guess most of the infrastructure designers and regulators, they are very familiar with it. New products such as rubber, still this is more in the research phase, right? So I tend to say this will be much easier to implement it compared to other non-traditional waste, you know, and it's just in the pool. My short answer is just a pool that people need to compare. Yes.
Thank you.
Thank you. Anne?
Just a very quick one from me. So we heard this morning that Stefano, you were talking about different lower tech options, you know, like if we can get away with doing less treatment and it's safe. I'm assuming that your models would be able to, once you build the framework, we can test different cost-benefit analyses alongside the safety and stuff. So I'm just flagging that that's a useful thing we can work on.
Yeah, I hope so too. There is one thing, especially when you talk about this non-marketing tangible kind of benefits, is that the system has to be at a certain scale. Otherwise, we do not see any impact on a very small scale, because people will not react to that, because they will not see, they will not notice. So that there is a certain scale assumption that we have to make, right? Because otherwise, if there is only 10 visitors in a year, that's not going to make any difference, right? $10, $5, so that's not going to make difference. Yeah, so there is an issue there. Yeah.
Can I add? I think there's going to be an interaction between social acceptance and technology, because although we can show, you know, the stuff doesn't go into the carrots, but the farmers and the users, the consumers, are they going to believe that? Are we going to be able to say in all possible scenarios this is the case? If we have a little bit of resistance or hesitance, it's not going to happen. If we have a system where we can control and we can produce data to generate confidence, that's probably what we need, even though it is not strictly needed from the point of view of safety. Just as a side.
Yep. And it's getting that data, and then it's disseminating it too, isn't it? In a digestible way for consumers. Any other questions? Yes.
Thank you. Howard from UQ. One question for Stefano. Are you going to look at greenhouse gas emissions in your experiments?
You are. So let me introduce to everyone this collaboration between University of Melbourne and UQ. We're going to do some of the greenhouse gas analysis with a group of Liu at the University of Queensland. And so we don't have that capability, but we believe that there's going to be an impact on greenhouse gas emissions. The moment we take nitrogen out of sewers, particularly we have less nitrogen that goes through the nitrification, denitrification process. So we expect there's going to be possible improvements, reduction of GHG emissions, but something that we're looking forward to try.
Yeah, maybe we can have an offline chat. And the second question, I'm very interested in your new campus and the MBR plant. I wonder, firstly, how did you persuade the leadership team to approve such proposal? And how do you do that? I always hope that you can have such facility.
So there was a call for living lab applications. We submitted a proposal for a water resilience living lab, water resilience and livability, something like that. And this includes not only this, it's going to be green roofs, it's going to be rainwater tank, stormwater collection. So it's going to be a holistic water living lab, and wastewater is part of it. So we're going to separate the black water from the yellow water, and we're going to generate fertilizer from the urine and generate purified recycled water from the remainder of the wastewater. Obviously, there's a huge amount of approvals involved. I mean, this has been going on for almost 2 years. So if you're going for it, you're in for a big effort.
Right, that's really fascinating. And one last question for Prahlad. The biocement idea is really fascinating. And I wonder what's the gas permeability of these biocements if it does block gas, like your application to landfill, etc. Would that block the emission of like methane, etc. from landfill and then effectively act as like a carbon capture sequestration technology?
It's a very good question. Obviously, this will impact the permeability. I tend to say it will reduce permeability. But I say it should come to that sweet spot that it becomes strong and permeability is not reduced significantly. I don't think necessarily for landfill this will become a big issue, because generally the permeability of landfill is very high. You know, like we have this gas collection system, because you have got a capping on top and it gets it, so means more or less gas is everywhere, right? But for other types of materials, it can be a bigger issue for clays or so on, but already it's there. It's a very good question. To be honest, we haven't gone that far to look at that, because we are more interested about the strengths. But I can see there is a good point there. But I think so probably the impact won't be so much, but I don't have any evidence to tell you that. But that's, yes.
Thank you.
Thank you. That's a good one.
Thanks for those questions. Dan? I'm not sure if that microphone's working, so.
I'll try and use my natural microphone.
Yes.
Let me know if you can't hear me. Yeah, I don't think this is working either. Is there a...
It's working.
Yeah,
it's working.
Oh, okay, sorry, there you go. Question for Said and Gam's research. Around whether you've chosen your case study sites yet, and if so, assuming there's sites, like will they be, city, a specific, city or community or whatnot, and how you're going to choose those, because obviously the results of your CBA will be very dependent on local conditions. And will you, for example, intentionally use case study sites, like what Abe showed, the Cape Cod example, where you could demonstrate in those kind of hotspot conditions, the huge avoided costs of not having to connect to the sewer, for example, or so just if you could talk a bit more about your case studies and how that might play out in demonstrating different CBA results. Yeah. Thanks.
No, we have not. We'll run an auction to go to the highest bidder to study. Just kidding. This is something we'll work collaboratively with the leadership team of ARC as well as other industry stakeholders. So we already have got industry funding, a small amount, so I think that's more for the primary stage, but they will be expecting at least one case study in Brisbane, because they already have put in some money, 15,000 or something. But but then otherwise this one is quite well advanced. Your case study also is quite advanced, it's planning stage. So it depends on like the availability of data. But I'm quite well aware of the issue that you have raised. Yes, performance would be quite local context specific, and that's where the sensitivity analysis part would be very important for us, and do a robust analysis on that. Yes.
I anticipate we'll work quite closely together with the PhD students on this. You guys get cross collaboration. Any other questions?
If I can add a comment, I just remember about your question. I think this technique we want to use for landfill is for old closed landfills. It's not for fresh new landfills, right? Because that degrades so much. So, and generally those landfills already the gas gone down a lot. So for fresh landfills, we like to extract methane. For something which is 30 or 50 years old, that's a bit of less of a concern. But I'd like to talk to you more on that. I think that's another aspect to consider.
Yeah, yeah, maybe new application.
I was going to suggest, because we have a few minutes left and this session is about urine collection, maybe we should give an update on regulation or how well we're trailing with influencing regulation and obtaining different types of approvals. And we have 3 nodes, so maybe we can do an introduction for each of the nodes. But for those who don't know the story, in Australia, plumbing codes are state-based, so each state has their own plumbing codes. They all refer to the same standards at the national level, but they are written different ways. So, and there's different pathways for obtaining these approvals. So it's really giving us a little bit of a headache. I don't know how it's like in the US, but certainly it's not something that we are moving very fast on. But there is definitely some movement there. So the idea is, if we're going to just go off-site and have a composting toilet, we're actually allowed to collect urine and do whatever we want with it, because that's not a plumbing system. The moment you plumb into the sewer, or if you call something a toilet, then you must send that waste into sewer, otherwise you're not compliant. You won't find a single plumber in Australia who's going to install it for you, because it's in breach of the plumbing code. And so we're working either on exemptions at the moment, or a path towards what is called watermark. So watermark is the certification of toilets and associated pipework that just basically tells plumber, you're good to go, you can install this, because it's been shown to work safely. So, all right, Brisbane node. Maybe Cara is the best person to give a brief update. Yeah, but
Yeah, so brief update with the Brisbane node. We've had some really good collaboration with our state government and local government folks. So and also urban utilities. We've got Matthew Mullis in the room, and he's been from urban utilities in Brisbane, so the water and waste guys there, and they've been working really well with all of the stakeholders. So now we're up to a point where I think they're changing a couple of sentences within the code to allow an exemption for research purposes for the Brisbane application, the Brisbane installation of the urine diversion toilets and the collection, which has been really good. It's taken a long time, but I think what's really helped is that the willingness of the stakeholders, particularly the state government stakeholders, so Queensland Health and Queensland Energy and Public Works and the plumbing and wastewater guys, have actually been willing to see this as innovative and not some crazy idea. They're seeing it as a when this is going to happen in the future, not an if. I think the Olympics in Brisbane's kind of helped them think, well, let's be a bit greener and more innovative and so on. But they could so easily, I did something about 20 or so years ago similar to this in Currumbin Eco Village, and they were much more reticent then. So 20 years on, they're really, we're working really well. So what we've probably only got, the time it takes for the minister to be briefed, and he may or may not be happy with it, and there'll be a bit of back and forth, but I think we're really confident that we'll be able to install those systems really well. But it would be really interesting to hear from our New South Wales counterparts or Victorian.
And we've been going at it only for 2 years or 3?
About 2-ish, yeah. But it's only been official. The NiCE sub's only been official since November last year, so it's not even been a year.
So.
No, look, it's slow, but it's just that ongoing relationship building, really. That's pretty much what's got us to where we've got, I think.
So to show how states work differently, in Victoria, things have been moving at a much faster pace, using a very different approach. And Southeast Water has been really
helpful there, particularly Paul at Southeast Water. And there's basically one piece of paper that has to be submitted. So that's greatly different. In Queensland, we need to amend the regulation to name the project and the project partner. And in Victoria, we just need to submit one form which will give us the exemption. Lee, do you have anything more detailed than this? Because this is roughly what I know.
I guess, just probably like you said, it's a different approach from state to state. And what I understand from my colleague is in Victoria, it's relatively, I guess, relatively fast process, but but we still need to go through the process and understand how it works. Yeah. But I understand, for example, our system will still actually need two types of the assumption. One is the plumbing part, and another one is if we use a new, let's say, urine diversion toilet, we also need to get a watermark exemption. So basically, two exemptions are required.
Yes, long term is the holy grail to have this watermark certified, and then basically we can use it as we wish. This goes for toilets, and those realistically will be watermarked because they're already used in other countries. The Laufen and the Worstman models, there's no reason to believe they won't be, but I think they want to watermark also the modular solutions that we implement to treat. And that's going to take much longer time. For the Sydney node, I know you got these urinals installed in this building already for 10 years. So you're the most experienced, except that those people who actually were here at the time have left. So, Sean, do you need to seek further approvals?
Definitely, we need to look at more, we are collecting urine and then try to processing and then convert to fertilizer. So you need to sell this fertilizer. So definitely you need to take out your urine and then you need some specific like a plumbing code, and then you need to process technology, and then you need to also put into the container your urine and as a fertilizer. So exemption of the resource recovery for circular economy, EPA, they are doing like a biosolid. Even biosolid, they need a lot of approval procedure because of PFAS or heavy metal as well as micropollutant inside the biosolid. So exactly same as our urine, we have also some kind of EPA approval procedure we have to go through for the exemption of the resource recovery. So that's the specific, the EPA, they are taking care of nowadays, the resource recovery related approval procedure. So that's the process of the certification of our urine fertilizer. So we have to go through how we can utilize. So there are several steps EPA proposed how you can utilize as a SDS safety data set. So we need to go through that kind of procedure. So also I'm sure that Dana, she has something to say for based on your experience of the collection of the downstairs. Right?
Yeah, I wish I could. I think I was in Sweden, so Dina would be able to answer that, but she is no longer with us. She would exactly know, yes, around the plumbing code issues and the installation side of it. So I wasn't actually here.
Is she traceable?
What's that?
I think so, yeah.
I can
Next
try. Should I
year.
dial a friend right now?
Well, you do that and we'll have morning tea. I don't think there's any more questions, so thanks everyone, and yeah, have some morning tea out the back there.
Glad it was well received.
Yes.
It wasn't,
Very, very. It was really comprehensive.
No longer, so